Hello and welcome to Chapter 2, Section 7, Comparing and Ordering Rational Numbers. So the thing to remember when we're comparing numbers and their fractions is when the denominators are the same, the bigger numerator is bigger. For example, 3/5 and 4/5. If we're talking about fifths, if we're talking about something that are the same size on the bottom, then if you have 4, you have more than if you have 3. The numerators are bigger and the denominators are same, then this one is bigger. If the numerators are the same and the denominators are different, then the bigger denominator is smaller. For instance, if I have 2/7 and 2/9, if I break something up into 7 pieces, if I take that same something and I break it into 9 pieces, these 9 pieces are going to be smaller than these 7 pieces. So I've got 2 of these and I've got 2 of those, and these 2 are going to be bigger. So when the numerators are the same, the bigger denominator is smaller. So this is the bigger number. Otherwise, if you have nothing that's the same, you have to find a common denominator. You can't just look at them and guess. So let's try a few. I have 5/6 and 6/10. I need to find a common denominator. Both of these will go into 30. And these are equivalent fractions. 6 times 5 is 30. 5 times 5 is 25. 10 times 3 is 30. 6 times 3 is 18. And 25 is bigger than 18. 5 and 9 will both go into 45. 5 times 9 is 45. 9 times 3 is 27. 9 times 5 is 45. 5 times 5 is 25. Now, 27 is bigger than 25, but look, these are negative numbers. And on a number line, the bigger the number, the bigger the digits, the smaller the number, the value is. So negative 25 is actually bigger than negative 27. Here we have 3 and 4/5 and 3 and 2/3. Fifths and thirds both go into 15. 5 times 3 is 15. 4 times 3 is 12. 3 times 5 is 15. 2 times 5 is 10. So I have 3 and 12/15 versus 3 and 10/15, and 12/15 are bigger. Now, also realize that if this is 3 and 4/5 and this is 4 and 3, I don't even care what it is, 4 is going to be bigger and you don't even have to look at the fractions. So that's bonus. So what happens when the things that you're comparing are decimals? Well, I need you to line up the decimals to make sure that we're looking at the same parts of the numbers and compare the columns. For example, 0.81 and 0.84, 0.81 and 0.84, this column is the same. We're comparing this column, and 4 is bigger than 1. Here we have negative numbers, 3.822 versus 3.819. 0.822 and 0.819, 22 is bigger than 19. So this is the bigger digits, but in negative number land, this is the bigger number. It's always backwards in negatives. This one can be tricky because this looks like 342 versus 34. Realize that this means it repeats. So this is really 3, 4, 3, 4, 3, 4, 3, 4, and it keeps going. Does that mean it's bigger than this one? Well, these two are the same and these two are the same, and we're actually just comparing these two. And here, this number is bigger, so we're going to put our greater than sign here. When you are asked to order fractions and decimals and they mix them up, your job is to make them the same before you go any farther. You can't compare them unless they're the same thing or they're obvious. So our example here, 3/5 0.77 repeating, negative 0.1, and 1 1/5, least to greatest. Well, some of these we can do right off the bat. I have one negative number. All positive numbers are going to be bigger than all negative numbers. So I'm going to say this one's the smallest because it's the only negative number. So I'm going to put negative 0.1 there. It's done. This number is the only one that's greater than 1. All of these are just fractions, somewhere between 0 and 1. So this is going to be the biggest, and it's going to go over here. I don't even have to, these two are the ones I have to compare. So this is a repeating decimal. I'm not going to be able to make this a fraction without rounding off. I can make my fraction, however, into a decimal easily. 3/5 times 2 is going to be 6/10, which is 0.6. And when I compare 0.6 to 0.77777, I can see that the 7 is bigger than the 6. So in least to greatest, it's 0.6 here and 0.77 here, but I have to make it look like this because this is how the answers are going to read. So instead of putting 0.6 here, I'm going to put 3/5 here, and I'm going to put my bar over that. So now these numbers look just like that. This is in order from least to greatest. And the last thing this set would like to show you is the definition for rational number. The term rational number means it can be written as a fraction. Rational means it's a part of a number. It's not a whole number. Now you have the tools to practice, so I'm going to ask you to try the guided practice numbers 1, 2, 3, 5, 6, 8, 9, 10. Do these problems on your guided practice page, push pause, and come back when you're done to check your answers. First up, we have 3/5 and 4/5. There's a common denominator, so my bigger numerator wins. Second up, I have common denominators, but these are negative numbers, which means the bigger the digits, the smaller the number, so this direction wins. Number 3, I've got uncommon denominators and uncommon numerators. What you can do one of two things. You can say times 2 times 2, and this becomes negative 4/6, and this is negative 4/7. Now in digits, we know that pieces of 6 are bigger than pieces of 7. So this number is bigger than that number. But in negative numbers, that means it's farther away from 0, which makes it actually a smaller number. That can be confusing. But according to that, 4/6 is bigger than 4/7. If you went the other route and you found common denominators, then negative 2/3 goes into 21, negative 14 times, and negative 4/7. 7 times 3 is 21, 4 times 3 is negative 12. So I'm comparing these numbers, and negative 14 is smaller than negative 12. And you want to do this because this is the bigger number, but because it's negative, this is our answer. Now, here we're comparing decimals, and these are positive, and our 6s are the same, and our 2s are the same, and we are comparing 2 and 5 is bigger. Here, this number is really 4, 5, 4, 5, 4, 5. Our 4s are the same. Our second digit, the 5, is bigger than the 0. So our 5 is bigger. Number 8, we're given decimals and fractions. We want to change 3/4 into a decimal so that we're all the same kind of number. And 3/4 equals 0.075. You can do the math, or you can check the math from section 6. We did that together. And we're ordering these from least to greatest. So at 0.5 and 0.5 and 0.7, I know that 0.7 is going to be the biggest number, so that's over there. I'm just comparing these two. Our first digit is a 5. Our second digit, that's a 5 and that's a 0. This one's going to be bigger than this one. So our smallest number is 505 and our middle number is 55 bar. And this number, of course, we have to make into 3/4 so we can correct it. Our next problem, 2.5, 2.05, and then whatever this ends up being. Well, 5 goes into 13 2 times with 3/5 left over. And if I go times 2, I end up with -2 and 6/10, which is -2 and 6/10. So I have 2.5 and 2.05 and -2.6. That negative number is smallest. I'm going to put it over here, but I'm going to put it so that it looks like an answer. But I know that it's smallest because it's the only negative one. Then I have to compare these two. Our first digit is 5, and 5 is bigger than 0. So this is our biggest number. This is our medium number, 2.05, then 2.5. Problem number 10. Again, we've got a negative number here, and the other two are positive. This is going first. 0.875. Now I just have to figure out if this one or that one is smaller. And I can do times 125 times 125 to get this into the thousandths. And 125 times 5 is 625. So this number is 0.625. And I'm comparing that with 0.877. This is going to be smallest. Oh, I'm going to do that so I can keep track of it. 0.625, 0.877. Those are our numbers. Your homework for this section starts on page 84. You're going to do numbers 11 through 39. Please remember, if you have any questions, make sure that you ask me so we can get through this together. Thank you much.